Here we have midterm exam 1, problem number 1. A long solid cylinder has a uniform volume charge density of 0.29 coulomb per meter cube across its volume. Find the magnitude of the electric field in the interior of the cylinder at a distance 2.74 meter from its axis. Assume that the permittivity of free space is 8.85 times 10 to the power of minus 12. Now, we have to find basically electric field at a distance of r. Say that it's positively charged, the solid cylinder, okay? So that means electric field will be pointing outwardly at a distance of small r. So we want to find what is the electric field at a distance of small r, okay? Now, so as you can see here, we have only charge volume density, radius, where we have to find electric field, and permittivity of free space. We don't know what is a big R or R, capital R of the solid cylinder. We don't know what is the total charge in the cylinder, and we don't know the H. If those things are not given, that means you have to assume that those things has to be cancelled out, okay? Now, okay, so how can we find it? The first of all, let's start with the formula where we have a flux is equal E times area, which is equal to the Q enclosed divided by epsilon naught. Okay, now we have to draw a Gaussian surface at the distance of small r from its axis. Okay, so that means what is the area? What is the area of this Gaussian surface? As you can see here, is this Gaussian surface of the cylinder. So that means we can say that electric field multiply area of this cylinder, which imaginary Gaussian surface, will be equal to the 2 pi r, then multiplied to the h, to the height, okay? And that's equal to the E enclosed. This small E enclosed means small charge, which is inside this Gaussian surface, okay? Inside the cylinder at a distance of r. Divided by epsilon naught. So that means we have to find electric field here. Electric field will be equal to the Q enclosed divided by 2 pi r h times epsilon naught. Okay. Now, how can we find the charge inside this Gaussian surface or inside the cylinder at a distance of small r? We know that the charge, okay, this one. We know that charge is proportional to the volume, right? And we also know that the charge per unit volume is equal to the total charge divided by the volume, or Q divided by V dash, okay? Okay, so we also know that total charge divided by small charge inside this small r of the cylinder is equal to the total volume divided by volume dash, okay? From here, we can find a Q, small charge inside this small cylinder at a distance of small r. Q is equal then Q times volume dash divided by the volume, right? We know that rho is equal Q over V. So that means rho times volume dash. Okay. Now, what else? What else we have to find? Now, what is the volume of the cylinder at the small distance, at the small r? That one will be rho times V. Volume of the cylinder will be pi r square multiplied to the height. Okay. So finally, we can say that the Q is equal to the rho pi small r square times h. So we take this and we'll plug it here. We plug it there, so we'll get what? We get rho pi r square h divided by 2 pi r h epsilon naught. So h will cancel, 1 r with another cancel, pi will cancel out. So finally you get rho times r divided to epsilon naught. Okay, now if you plug the numbers, you should get the right answer.